Yo, what's up, everybody? Welcome back. Today we are working on our video game, and today's topic is trying to get a skeleton deformation applied in like a OpenGL app. So, this is our little main character. You know, he's got a little wooden sword and shield. He's a little goofball, right? And he runs. He's like tilted back. He's kind of an idiot, right? And we are trying to like use this guy and his animation in like a game that we're making, in like our own game engine, you could call it, right? In reality, we're just kind of like using OpenGL and like importing this guy. So, you know, we've managed to like parse the gltf file exported by Blender. We've like managed to find the mesh. We have our little guy T-posing. We have not finished importing all the textures yet and stuff, but like whatever. We have like a little guy, right? And we've also managed to import his skeleton at this point. So we found all of his bones. We've rendered them with little bone models because, of course, the bones are bones, if you think about it. And, you know, we have our little running animation. But what we have not figured out yet is how to make it so that when he's running, the mesh gets deformed. And so that's kind of like today's goal, is to try to figure out, like, how are the vertices on this mesh tied back to these bones? How are they represented in like the exported file format, and then like we need to like do that thing, right? And then if that we get through all of that pretty quick, we also need to figure out like how do we animate like multiple guys. We have to figure out how we're going to store them in like our application and stuff like that. So because right now we are modifying some like bone objects here, right? And I guess like we're going to have to like copy paste this entire armature for every single guy that we instance or something. I don't know, we'll have to think about it. So this is fun. Let's jump in. Let's get moving. Okay. So, I guess step one is to try to figure out where this stuff is in like the gltf file. So Blender, we have like some Blender file called something.blend. We go in here, kind of hand wavy. Our build process will like automatically export these things, but it's kind of doing something equivalent to going and clicking this like export as gltf button, right? And this thing spits out like a JSON blob with some binary data, and in that JSON blob, surely we have some way to like tie back how all of this stuff works together, right? So how this stuff works from like a Blender perspective slash like animation perspective is we have like our skeleton, right? So can we like show the skeleton here, right? And this is kind of like a very low resolution version of our guy, right? It's not really like what we're seeing here. This guy's got like all sorts of like vertices on him, right? And each of these vertices need to be like deformed by those bones by some amount. And so what we've done is we've gone into like weight paint mode here, and like each vertex for each bone has kind of like a strength of how that bone applies to this mesh. So I don't really know, but I'm kind of assuming that what happens here is like you take the rotation of the bone, right? And you like rotate probably like these parts of the mesh, like, you know, these vertices or whatever, you like rotate them around the pivot point of this bone, I would assume, by like some amount defined by the color of this thing. That would be my assumption. I don't really know, but that's my guess. And so somewhere in this like exported file, we must have this like heat map somewhere, and like a definition of how that heat map ties back to like a specific bone, right? Surely. And so let's see if we can like find that in here somewhere. So we know that the bones are kind of like just objects in here. We have a kind of like a root nodes array. This like gltf file format is very like flat. Right? If we like open this up, we have like a top level thing where we have like all of our buffers, all of our samplers, all of our buffers, all of our like images, textures, skins, meshes, right? And so we have like nodes here, which is kind of like an object. It has like a thing with like a translation and a rotation and a scale, maybe a mesh, maybe some children, right? But it's like a thing, right? So all of our bones are kind of like things here, right? Then there must be somewhere where we like attach this to our armatures. So how did we pull out the armature again? I think it was under skins. So skins, we have joints. Yes. And all of these joints are where we're reading the bones from. We're saying, okay, so these objects are specifically objects related to some armature, which I guess is probably this skin. That would be my guess. And so in our like nodes array here. One of these guys is like us. So tooth, I guess like the tooth is deformed by the mesh. Or by the armature. We kind of like tilt this tooth with the pose. I think that's kind of wrong, to be honest. I think that we shouldn't be like animating him with the bones of the skeleton, but we are kind of doing it that way. So yeah, you can kind of see like here he's kind of like tilted back with his spine. So this skin 0 would be my guess, is like he is saying that this mesh is deformed by this skin, right? And so what this does not have though, this does not tell us the mapping of like which bones this tooth is deformed by. That's not clear. It might be part of the mesh. So he's kind of saying this is mesh 6, right? So 1, 0, 1, 2, 3, 4, 5, 6. Okay. So we have something that's like his, let's double check here. This thing is called plane. So if we look at his tooth are cone 002 and cone 005. Okay, so this one. So this guy has a weights field in here. Found a better one, I think. If you're interested, set FDM equals marker, FMR equals, oh, for like showing overview of the file. Yeah, I see. So this guy does have a weights field and a joints field. So I would assume that this tells us like which joints are relevant from the skin, right? We know that our skin has like a bunch of bones that are called joints, and presumably this is like the weights associated with that thing. So maybe we can like look at the gltf spec and see if we can confirm that in some way. So this is like related to meshes, which are kind of like where all the vertices for my guy are, kind of hand wavy concepts. Meshes, geometry, meshes. Yeah, here we go. So can we see what these guys mean? See skinned mesh attributes? Okay. Skinned mesh must have vertex attributes that are used in skinning calculations. Joints attribute data contains the indices of the joints from the corresponding skin.joints array. Okay. The weights n attribute data defines the weights, indicating how strongly the joint influences the vertex. Sure. So to apply skinning, a transformation is computed for each joint. Then the per vertex transformation matrices are computed as weighted linear sums of the joint transformation matrices. Note that per joint inverse bind matrices must be applied before the base note transforms. Okay. I don't know what this means, but sure. So unsigned byte or unsigned short is joints n. So this is kind of like, okay, so if I understand this correctly, we kind of have like binary data over here. And in this binary data, given his face, I'd assume he has multiple joints. He even smokes them. In this binary, somewhere there's like joints and weights. And this is telling us how to like access those things. So they have like a definition, joints 0 at index 49. So there's somewhere in like the JSON blob that kind of says like, hey, 49 is like ints, and there's like 50 of them, and like they're at offset 1, 2, 3, 4 in the binary, right? So I think what we're saying is like which joints we use for this particular part of the mesh is over there somewhere. And the weights, these must be like per vertex. I don't know if joints is per vertex. It might be. This might be saying like, hey, this vertex uses bone 5 and 6, but like don't worry about the rest. It might. I don't know what else this would be. Yeah, it has to be. It would have to be. Or else why would this be here? So we could take a look at this and see. We can try to like confirm our theories. So where was that? That was in mesh. Mesh, joints, and weights. Okay. So in our like gltf abstraction, somewhere in this guy, we should be able to add to like the mesh here, primitives, attributes. Here, we should be able to be like weights and joints. And presumably this is not the correct way to do this, right? Like because who knows how many joints or weights fields we might have. Like it looks like these guys have like the ability to not have like a zero on them, right? But we can just kind of hard code the zero there because fuck it. We're not really writing like a generic gltf parser. We're writing a gltf parser that works for the things that we are exporting as our part of our game. So if it comes to the point where we need to support many joints and weights fields, then we will. But likely that will never happen, and so we can just kind of get away with this for now. Probably. Probably. Right? Then somewhere we call load gltf. And in here, we must want to attach that data to our like our GPU buffers, I would assume. I would assume that like all animations for this stuff are done like on GPU. And like the CPU doesn't have to care about it. The CPU might have like a physics body that's kind of like a representation, like a ball around this guy, but in like like really in terms of like individual vertex manipulation, he doesn't care. He doesn't give a fuck at all. So we should probably do this in like mesh parsing. I think that makes sense. So somewhere we're going over like primitive indices, and this guy's looking at like here, position accessor, normals accessor. So here we should be like joints accessor index is primitive attributes joint 0. And I guess here we kind of only do this, we kind of like do this at the end or something. And maybe like we kind of if this thing. So we say like, if you have this thing, we're going to do something with it. I don't know what yet, but we're going to do something. Okay. And can we look at that thing? So here we have like, I think this is probably an accessor. So it's like accessors at joints index. This is like joints metadata. And I think we can probably say like we have like weights metadata as well. Presumably if we have joints, in the one case that we have, if we have joints, we also have weights, right? So this is primitive attributes weights, or else I guess we just crash. That seems kind of reasonable. Because like we get to define, we get to like control what assets are fed into this thing, so we don't have to worry about like being error correct here, right? If we feed in something that doesn't have joints and weights set, then we'll just crash, and that's on us. Which means that we have weights metadata as well, if we just look at it. So can we like print this stuff for now and just take a little peek-sees at what we have? So this is joints and weights. Okay. Cool. Let's see what happens. Okay, so we do start to see the stuff. We see that our joints data has type of unsigned byte, and there's 559 of them. So that's a lot. That's a big number, and I assume that's the number of vertices on our guy. We can check that to see if that lines up with the number of like normals we have, right? So we can like kind of say, like, where is this stuff used? Position data, positions, vpause goes into here. So this is like out buff. Sure. So if we like print like number of vertices is going to be out buff lan or something. Oh, interesting. Interesting. Okay. Oh, buff items land, and then it would be kind of. Yeah, it's kind of awkward, but I guess we'll just kind of like log it here. Fuck it. Okay. So this does not line up cleanly, right? We have 280 vertices, but 559 joint things. So it's not clear to me what this is. Right? That's confusing. Confusing for sure. So, like, what the fuck is this thing? Um, Joint weights for each vertex must not be negative. Okay. Oh. Hold on. So this out buffer is like, this is like we have, you know, points one, two. If you have like 4 points and 2 triangles, this is kind of like this, right? And so the way that we're kind of representing this in our application is that this is 6 points, but this was like might have come from something that was 4 points that is indexed, right? So if they have like 0 index 0 1 2 3, they might say 0 1 2 1 2 3, and then we convert this into just like the points directly. But that's not necessarily how this is stored. So if they have indices, it might be that like we might want to count the number of indices as well and see if that lines up. So maybe like something like this. Okay. Oh, sorry. Number of indices is this. Number of vertices comes from positions. Maybe. Okay, but maybe divide by 3 because it's 3 points per position. Maybe? There we go. 559, 559. I see. I see. Okay. So, what does this mean? This means that for each vertex that we put on the GPU, we need to attach this like vertex color, which is fine. Right? So I think maybe we have to think about this. So for each vertex, we have one joint. Is that what it's saying? We need to look at like the values of these joints things to gain intuition about them, I think. So we're seeing that the joints are unsigned byte vec4s. That's interesting. So each joint has four indexes maybe into the joints array. That would make sense. So like this could be saying like, hey, you have influence from up to 4 bones. No more than 4. You cannot be influenced by 10 bones. And these are going to be your weights for each of those 4. Could be. So we can kind of just mirror this on the GPU for a sec. And oh, let's just kind of read the data first. So, okay. So we need to like map the data from the binary file. So access our data at joints index. This is joints buff, I guess. This gives me back a slice of U8s. So now we do like std mem bytes as slice of whatever like the type of the joints buff is. So here we probably want to like assert that the joints metadata dot component type is what we expect. So we saw component type was unsigned byte. And we want to assert that the type is vec4. So we're asserting these two things. 1.mkv. What the fuck are you doing? Are you okay? First time chat 1.mkv. Sorry, no worries. Oh, remember good. Thanks for the prime. Much appreciated. I missed that one. Okay. So now we can say we have asserted this, and so we can be fairly confident that this thing doesn't even have to be remapped. He's already U8s. So for 0 to joints buff LAN over 4, probably, because we know it's a vec4, we're going to look at like, you know, joint for vertex I has these parameters, right? Let's kind of just take a little peeksies and see if we can understand, like, gain some intuition about this shit. So here we're gonna look at I, and we're gonna look at start is equal to I times 4, and then end is equal to start plus 4. Cool. Yes, I need to. What are you talking about, dude? Chill out. Joints buff from start to end. Okay. Let's see. Okay. So this is not crazy. Those are reasonable numbers, right? We're seeing everything is kind of, you know, hand wavy between 0 and 13. I think 13's kind of like, 15 here. Okay. And so if we look at like the joints buffer in like zig out, share, character, asset, gltf, we look for the skins section. This guy looks like, it's hard for me to know whether these are indexes into this joints array or if they're direct node IDs. I would assume that it's indexes into this joints arrays. All right, that's kind of just what I would assume. But I'm not really sure. But we can assume that for now, and then it'll become, because they're not in the same order, it will become obvious pretty quickly, I think, if it's wrong. Sure. Fuck it. Sure. Okay. Now we probably also want to look at like the weights for this. So we're kind of assuming that these are like in lockstep. So we probably want to look at like weights buff like this from the weights index. And we probably want to look at like, I think these are expected to be floats, and we're also expecting 4 of them per, right? So can we say joint for vertex this, and like weights for joint is gonna be, you know, something like this, just like weights. Here we need to convert the weights into a set of floats. So we're gonna do like std mem bytes as slice. These things should be F32s now. And now let's just kind of see if that tells us anything interesting. He's mad. Why? Because it's not a float. What is it then? component type is float, is it not? Oh, weights. My bad. My bad. What's up? How's everyone here? Good. How are you? What's up? What's up? What's up? Okay. So this thing, what is this good thing saying? So for 0 is 0, which is kind of interesting. Here 0 is not 0, so it looks like they probably like the 0 might be an index into the joints array, but it also might be just kind of like their value for like I don't give a fuck. And it's just like, you know, it just depends on whether or not there's a value in the weights array for this thing. But I think this makes sense. I think this makes sense. So I think what we can do is we can try to visualize the weights for this thing. I think that's probably like the next step here is try to like just paint them in some way on our character. So can we say like visualize weights? Yeah. So how would we do that? We pipe in weight data for each vertex and joint. We just kind of like pipe this data directly into the vertex shader, I think. So we have like our model renderer, and he has a vertex shader in here. And if we're just like, yo, you have, can you do like, what are my like options here? GLTF data types. Am I like fucking stupid? Probably. Not GLTF, dude, GLSL. God damn it. What are our options? I assume like int, bool, int, uint. Probably uint, right? So this is like joint IDs, except this is 4 of them, right? So we want like uvec4 for a vector of unsigned integers, and in uvec4 or vec4 weights, except I don't like this. I'm trying to think like what's the easiest way to hack this for now. I think this is the easiest way for now. Don't judge me. Don't judge me. It's just because like I just don't think that we have the piping right now to easily hook up like uvec4. I guess uvec4, like how hard could it be? uvec4 makes sense. Fuck it. Fuck it, fuck it, fuck it, fuck it. No, not fuck it. We'll just do this. Fix me uvec4. Perfect. Sure. So that means that now in our side, on the CPU side of things, our storage has this like model vertex thing, and in here we just have, I guess we like throw in V's on these things. I guess. And then here we copy paste this into this structure. And then it kind of like automatically, like our code automatically will like upload these correctly as long as they are in this thing. So this is U32. And this is v weights as a vec4. Okay. If these don't upload cleanly right now, then like we'll figure it out. So probably we want to do like these are optional. No, let's make them mandatory. Let's make them mandatory. Okay, so this guy is gonna be like, yo, you need to set this shit up. So in this case, I guess that means that we're going to like, as we're parsing out all of the like positions and stuff, we are going to like probably do all of this stuff that we just did where we like get the buffers for these things. We need to like have them available to us. So if, let's think about this for a second. I think it's easiest for us if we just kind of have our like joints buffer here as this is kind of like a hack. But we could do like allocate something from the scratch space. Right? And we could just allocate like some positions len times 4, right? 4 joints for each vertex. And then our weights is the same but for floating point. Right? We could kind of do this. And then if we have this stuff, we can just override it, right? So if we have the joints thing, then we reassign joints to be this. And if we have weights, then we override the weights field to be this. And now we can like index into these things in either the case where they're present or not, and everything should kind of just work out, I think. So now when we're like appending this stuff, it's just like uh joints is like v joints is joints from start joint, I guess, is I times 4 end joint is start joint plus 4. Is that right? I think so. Yeah, it feels like it. So then this is like joints at start joint, I guess. 1, 2, 3 is like plus 1, 2, 3. And then we have like the weights is going to be, I guess, something that resembles this. Yeah. But just one more, I guess, which means that like we need v weights is equal to weights from start joint to end joint or something. That feels kind of right. No inversion here. That's like a maybe, okay? And then we have to apply the same thing on the other side for when we're just like indexing these guys directly. So we kind of need these same things, except this is, yeah, this is all the same. Yes, okay. This is all the same. So I'm just gonna throw fix me on here and be like, this is all the same as the indices path. Weirdly, confusingly. All right. Cool. That's annoying. Joints. Do we have to do like this? It's kind of. I guess so. That's weird. But whatever it is, what it is. All right. Oops. Const. Hello. Const. There we go. Now. We're gonna align cast this, I guess. And just hope to God that all kind of works. I guess we'll run it, and if we don't crash, we're chilling. Oh. Interesting. So we don't support U32s here yet. But I guess we will. Unsigned in, probably. This is sketchy. This is sketchy. Still unknown type? What are my... Oh, because we also have vec4 here as well. These are new. These are new. Auto-propagating stuff needs to have the right fucking types in there. Which means that probably just using a UVec would have been fine. So everything's here. Cool. And can we now do something like just render the weight in the fragment shader? So in our like model fragment, can we just do like out float weight? Weight is equal to v weights 0. I don't know if you can index into a vector like this. We'll see. And then here, can we just like render according to that instead? It's like, oh, we don't have it in float weight, and then we just do like weight here, like this. So this should show us the weight of some bone. Oh, I see. So this is showing us the weight of any bone, kind of. So this does kind of line up. We're seeing like kind of like dark spots in the armpits and stuff, which kind of makes sense, right? So there are kind of some places that are where the weights are applied less for bones. So that's promising. Now it would be kind of nice to like filter for joint ID, right? So let's look at can we do like uniform uint joint ID is equal to 0, right? And so we want to kind of walk the joints here and pick the right one, I think. Right? So we go like for can we do like, I don't know, uint for joints? I don't really know how like this language works. I think it's like this. Right, I think. For int uint I equals 0, I is less than 4, I plus plus. We probably do some like if joints I is equal to joint ID, then we say weight is equal to v weights at I. Otherwise, weight is equal to 0, right? That seems like it would probably do something sane. Let's see. He's gonna crash. Because we're doing something shit. Initializer of type int cannot be assigned to variable of type uint. So here we have to do uints in all of these probably, and that's might not even be where he was complaining, to be honest. He was at 23, so that was here. Okay, let's try that. Let's try that. Fuck. So this is at 23 again. C-style initialization requires this thing. So how the fuck do you initialize an array? GLSL init array. So it's like this. Float A5. So it's uint joints 4 is equal to float 4. Or fuck, not float. God damn it. Uint 4. Alright, let's try that. Let's try that. Okay, so now he's mad at 22 because what? This is supposed to be parentheses, not curly braces? Is this Ubuntu? No. And it's not really that relevant. 27 is mad because you're not allowed trailing commas in this fucking garbage language. I shouldn't be that mad. GLSL's kind of hype. Okay. 30 is mad because... Dude, really? You really need to do this everywhere? What a crazy language. What a crazy language. Uh, 16. Another uint bullshit. Dude, that's crazy. I don't want to type uint everywhere. I think that uints should be nice to use. They're unsigned. We use them sometimes. Fuck. 9 Hello? Shader, oh, maybe this is in the other one? Oh, yeah. I accidentally had something in the frame shader. Hi, I've got friends who program GLSL every day and they all hate it. That makes sense. Um, maybe? Maybe. That's not crazy. Okay, can we make some sort of like a UI element that lets us kind of see all of the different, like, lets us like select a joint now? That seems kind of hype. So I guess that's kind of like, for some reason this lives in storage, but I think we should be able to like be like joint ID as a U32 here. And then in main, when we like construct our sidebar of UI elements, we should be able to make like a combo box that lists all of the different joint IDs. Or maybe just like a drag thing that selects joint IDs. Yeah, let's do that. We'll say like a max joint ID. We don't even need to do that. We can just do like layout push widget try like widget factory make drag float. This is kind of a funny way to do this, but it's fine. This is like action gen. So his retriever is going to be like some way to get the current joint ID, which I guess is going to be like joint ID, I guess. Sure. Then his generator is going to be like UI action make update joint ID, and he's going to be like move in steps of one. Maybe? Sure. And then what is this layout? This should go on property list, probably. Should go on the property list, and that means that this thing should have like a label that's like make label, and we'll say like joint ID. Preview joint like this, I guess. Sure, blaze it, fuck it, whatever. So this should give us something in the sidebar that lets us like change the joint ID that we're like visualizing, but it means that on make UI, this thing needs to be in here. So this again is fucking weird, but it's fine. So we're throwing in a float here because we don't have like an integer selector in our GUI framework. We only have a float selector, but we can just kind of clamp the values that it will accept to be integer snapped, and then it's fine. So we should be able to be like, the GUI is gonna like ask us to like update. I don't remember what we called it. Update joint ID. He's gonna like, here's a floating point number that we would like you to set, sir. And we'll just be like, fuck you. I assume it's like something like this. So like in main, when we're like handling requests from the UI, we'll just be like update joint ID. And here we'll just be like ID is equal floor ID. Cool. And then when we are then applying somewhere, we're going to be like, hey, we need to pass this joint ID in. So here, I guess, wherever the fuck we are, we'll pass it in. Joint ID is a U32. Cool. And then someone's going to be like, yo, you need to do that. So int from float of joint ID. This one's just 0. Fuck it. Okay, there's another one, though. Another one! I think it's this one. Alright. Okay, so that all compiles, which is kind of nice. So let's kind of see if it works. Out of memory. Oh, because our property list kind of like pre-allocates however many fields we're going to be putting into him, but we now have added some fields to the property list. We have to update the pre-allocated size, and let's see. Okay, so we do need to clamp this shit. So here we're going to be like clamp. I think it's like std math clamp this thing from 0 to 10 or something. Fix me like actually find number of joints, but this is fine for now. We'll just allow it to be 0 to 10, and then so this is not promising. The fact that we are only seeing joint 0 here is confusing. Can we like crank this up to like 20? Yeah, that's not good. That's not good. I was kind of hoping to see it kind of flip around there. So what do we do here? We try to... Okay, so there's like lots of ways that we could have fucked this up, right? Lots of ways. We could not be correctly populating these, right? That's quite possible. It's possible that we are not correctly indexing the weights. We're not correctly populating the weights. I guess we know that... do we know anything about this? We only know that weights 0 is valid. Let's do weights joint ID here, and that will kind of like hit 2 birds with 1 stone. So if we huck this in here, we should be able to index from 0 to 4, and we should be able to see at the very least something change. Right, so here we're on preview joint, like the weight 0, weight 1, weight 2, weight 3. So okay, it looks like kind of like hand wavy. The data in here is kind of like going from like most area covered to least area covered. But these, at the very least, all indexes into the weights array have what seems to be reasonable data to me, right? Like you can kind of see that like index 1 is kind of filling in the holes that index 0 is not covering, right? So that's a good sign. Now it seems like it's like the joints array is our problem. So we could try to visualize that somehow. If we passed the joint ID over to the fragment shader, we could like pick from some sort of like color matrix or something just to like see. Yeah. Let's just mask out here. If joints equals joint ID, then we'll color it white. So we can kind of do like, if joints, if we see a joint with joint ID, weight equals 1.0. Right? That should give us a clue here. Right? So then we can see who is affected by which one. So here, this is kind of saying 0, there's a lot of zeros in there. So we're not seeing any joint anywhere with joint ID 2. So either we are not passing in the right thing, right? Either this is broken or these are broken. So we can bisect that by saying if joint ID is equal to 2, weight equals 1.0. Right? If we do that, then we should see the weight. Fuck. You went 2. My bad. My bad, bro. Now when we set the uniform value to 2, we should see the guy like light the fuck up, which we are. So this means that the uniform uint that's being passed in is correctly making it here. So we know that joint ID is valid now. We have a fair confidence in v weights. we do not have confidence in the joints value here because this is not working, right? Which means that this is probably not working. So can we look at the values that we're passing in here? Let's just, now we'll color it if v joint id 0, if this is not equal to 0, weight equals 1.0. Because this will tell us if at least it's getting a non-zero value, if we're like if we're passing anything reasonable in here. Fuck. V joint, oh, it's like this, id 0. And is it lowercase I? Lowercase I. Which maybe is the clue that we're fucking up. Okay. So can we say like if v joint id is equal to like 1? Let's try that. Is it getting like garbage data or like what, you know? Okay, so that's a good clue. That's a really good clue. So literally nobody has joint ID 1 anywhere, which I'm pretty sure is wrong. This does not sound right to me. So it could be that like we didn't name these correctly. V joint ID. No, that sure is right. It could be that like this parsing here is not right. So it'd be kind of interesting to maybe print out what we put into this out buffer. Right, this should give us a clue. Vert, smile. What are we doing wrong, baby? Okay. So like, can we look at 4? We're seeing a lot of 4, 0, 0, 0. Okay. So this should be going up. Okay. I guess maybe like we should be seeing a lot of similar vertices, like similar joint indexes. We could check. Okay, so given this info, we could look at the vertex shader and check if this is equal to 4, because apparently there's a lot of guys equal to 4 in here, right? Supposedly. So we hear. But they are not. So that's a clue for sure. How? Okay, so how the fuck is this stuff used? We were using some like Zig compile time reflection that might be like kind of fucking us here. So we create one of these buffers from this like vertex type. We have this initial data. In here, we say, hey, we are trying to like, this thing is a U32. This might be wrong. This could be wrong. So this is elem type. Can we look at the function here? So we're looking for the 0, 1, 2 third parameter, 0, 1, 2 on one of these. Vertex array attribute format, 0, 1, 2, 3. So GL type. Type is the type of data stored in the array. Type. Tell me what my options are. Type is one of. Aha! Unsigned. Ooh. Respectively, the value is GL inside byte, GL inside short, and GL inside int. Indicate types these, respectively. Okay. So it seems like the value of GL unsigned int is reasonable here. Seems like it. Hand wavy. It would be interesting to kind of hard code like 4s everywhere or something, right? Just like hard code 4 here, right? And here. Actually, are we making changes on both sides? Yeah, okay. So let's hardcode 4 and see if that makes it so that when we ask for 4, that, okay, that's a good clue. So that means that in our vertex shader, unless we've done something like really wrong here, this is not happening, right? Yeah, that's interesting. So can we do like if lm type is equal to int, can we do like, can we just like, I mean, okay, if, oh, okay, can we check for like not setting this? Not setting. This would make a lot of sense. If that log comes up, then we're doing something fucking wrong, and I just have to find it. Okay. So can we look at even what, like, for what reason? We're back with Mr. Bang CPU Arch. Classic. Okay, so this means, okay, what is like field here? Inline for field, field locks, field name. Okay, not setting field name. I'm a new game dev. I'm working on a project, struggling to find my game's identity when I'm taking inspiration from various other games. Do you have a more personal take on creating? Dude, I don't know anything. Let's be clear. I don't know jack shit. I'm just a guy. So I've never really made a game before, so I'm doing something that I think is reasonable, but I don't really have any like advice for you. Any advice I give is like the blind leading the blind. Okay, so this is kind of interesting. V norm and V weights are not being set in some cases, which makes sense because V norm and V weights are not being used anymore because they're commented out. So that means that like the joint stuff is being set, right? We should be seeing like, if we call setting here, we should be seeing him spamming setting V joint 0 or whatever. Yeah, here we are seeing that. So at the very least, we're attempting to set this data. And so what's the problem? It might be that when these guys are integer types, we have to do something else. Offset here is offset of this thing in the structure. That makes sense. We enable the attribute. Yeah, interesting. This feels okay to me. Hand wavy. If we set this to like glint, I'm curious to know if that changes anything. I don't think it should, but it could. Clearly not. The other option here is that like somehow we've got GL unsigned. No, GL unsigned, it has to be it. It has to. Interesting, interesting, interesting. I feel like this shouldn't be this hard. Can we maybe look at here? Like just what is being passed into this guy? Let's just kind of like make sure that we understand everything correctly. So we should be seeing initial data. We should be seeing joint 0 should be hard coded to 4 all over the place, right? So v joint ID 0, 4. V joint ID 0, 4. V joint ID 0, 4. It's everywhere, right? We're seeing that shit left, right, and fucking center. My fucking Tmux is crashing, I guess, for some reason. Probably because this is like one really long fucking line. Let me out, sir. Dude, that's crazy. All right, clear. So it seems like we should be sending the right stuff up. Binding index, what is this? Yeah, sure. That's fine. That's fine. Interesting. We are enabling the thing. I wonder if it's like... No, every single v joint ID 0 is getting set to 0. So the fact that this is ever not the case is very confusing to me. Can we set like default values here? Is that like allowed? And if so, does that change the behavior? No, that's not allowed. Long lines kill so many editors is crazy. Dude, yeah, this isn't even like an editor. It's just like my fucking terminal. Sorry for such an out of context question, but have you tried Ghosty? Yeah, I mean, I opened it once. I didn't really see it's like fine. I don't know. I don't really care. Doesn't really like matter to me. This is so strange. GLSL inuint not working. This is like the stupidest thing I've ever fucking punched into Google, but oh. Oh, I've been fucking bit by this shit. Yeah, okay. Yep. You need to throw a fucking I in there. A fucking course. A fucking course. A fucking course. God damn it. I should have known. I should have known. So if it's like one of these, we do this shit. And if it's this, we have to call the other function a fucking fuck course, you know? So somewhere there's gonna be a little I in here. Like this. And it's object, attribute index, size. So no more num elms. But maybe size is num elms. Number of values per vertex that are stored in the array. So that is still num el, like, sure, that's the same. Okay, this is the same, this is the same, this is the same, this is the same, and it's just normalize goes away. Normalize is not a thing that makes sense because it's an integer. Of course. Oops. So it's literally the same shit just without the normalize field. Oopies. Life is hard sometimes. 4, baby! Let's fucking go! Okay. So, now we should be able to go back into this guy and, like, try to do something sane. So, what were we doing before? My ears, sorry, I was excited. Calm down. Sorry. It's your fault for having ears. So now we should be able to set the weight according to which bone we're looking at. So here we're looking at joint 0, joint... Yeah, okay. So I think this kind of makes sense. We probably, like, let's do the, like, red to blue shit that they do in Blender. So can we do, like, in the fragment shader? It's like vec3 red is blue is like this, RGB, and then we do like a mix red, blue, weight or something. Mix GSL. My apologies, yeah. Good. I'm glad you're apologizing to me. Yeah. Okay, so this should like kind of get us from red to blue, kind of depending on the strength. Probably other way around, huh? Other way round, I guess. Okay, so can we look at like... I'm a little concerned about this. It's like everything down here is just like not fucking getting hit, which is very strange. Like we would assume, I thought. Like this does not match up with what I see in Blender at all, right? Like if we go into Blender, this is what I'm kind of expecting to see, right? Like I select bone 2 and I should be seeing something that looks more like this, you know? And so the question is like, why am I not? Right, we kind of have this thing, which is like literally like one. Oh, because I'm fucking lying. It's because we didn't undo our hack in the like gltf parsing where we just hard set this shit to 4. That would do it, huh? That would do it. I forgot about this. This is what we get for exploring and trying things. We just like leave. There we go. Okay. Okay. That looks kind of nice. That's a really good sign, right? So we're seeing like, boom. So we have joint 2, 3, 4. Yeah. Okay. So now we can start tying back like which bones are which probably. Right? We probably want to like look at um we're probably going to have like some sort of like bones, right? Why is this so fucked up? By the way. Like that looks really fucking weird. But maybe we don't think about it. Maybe it's like it's so weird that this is so like nicely gradiented and then this one's just like go fuck yourself. Like unless 0 means not affected by any joint, that's possible. Yeah, it feels like it should be kind of more like this, right? Right? Like that's what I would expect. And here instead we're seeing like whatever the fuck this is. You know? So that's kind of fucking weird. Very strange. And like is guaranteed to cause us problems. Yeah, so like what it's something special about joint ID 0, which I think makes sense because we saw a bunch of joint ID 0s for like invalid weights, right? However, there were things that had joint ID 0 with set something. Is it possible that this is like broken somehow? Like, are we looking at the wrong body? This is from character.blend, which should be exported. We could like RM the GLTF and get it re-exported. The fact that everything else is so smooth is like really suspect. Very, very fucking suspect. That's just so strange. Right? This does not match up with this at all. but I don't feel like we're doing anything like unique here. V weights 0, 1, 2, 3. V weights start joint to end joint. It's like, how could it be wrong on all of them but joint ID 0? It just doesn't make sense to me. It just does not make sense. Model renderer. So we just have pass in joint ID here. We have model vertex shader. If joints I has joint ID, this joint ID, then we show the weights at this thing. Otherwise, he gets a weight of 0. Can we have like the default be 1 here and just see how that, like, if we don't find the joint, how does that affect us? Weirdly, this doesn't change, right? So there's something. Ooh. And V weight, and the weight is larger than 0. That might be something here. Like, we might be overriding it. Yes. Okay. Nice. That's much better. So what we were seeing there is we had like a joint like 0, 1, 0, 0, right? Here we were like kind of like using these two, and these two were invalid. So we had like weights like 99, 50, or probably 0 to 1, right? So this is like 0 0.6, 0 0.4, 0, 0, right? And so what was happening is we were like iterating these, right? And then overwriting this 0 0.6 with these zeros. And we just had to like guard that case. So it's a good thing we visualized this. Hype. Okay, so now that's way more reasonable. Hell yeah, dude. Hell yeah. Okay, so that's a really good sign. We have everything we need. We just have to do the deforming now, right? I can't use shading languages without pointers. With like, I don't. Does GLSL not have pointers? I guess not. What would you need a pointer for? Like, does it come up that much? It's not like you're like interfacing with raw memory very often, right? GLSL kind of handles most of that for you. But I could see like in some cases like being able to do like a ternary where you say like if this thing point to that, otherwise point to that thing. I can kind of see that. Okay. So how do we now deform this guy? So in the gltf spec, it was talking about linearly interpolating something. So, I mean, what if we were to just like think about this, right? We have in our little example application, we have these bone transforms, right? Womp, 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 womp. And like each of these bones is attached to the joint matrix, I assume. I have pointer to point and laugh at your code. God damn it. So I guess we probably feed in the transform of every bone into the shader and like use that somehow, right? Right, surely. Surely. So in here, we probably have like uniform mat 4x4 bone transforms. And there's probably like some max bones number of them, right? Could you use defines in GLSL for this? Is it like they do have a pound define, so we could do like max bones is like 20, right? Okay. Then instead of doing whatever the fuck we're doing here, we look up the bone transform. So it's probably like GL. Ooh, this is interesting because the normal vectors are going to be affected as well. Okay, but just probably fine. You probably do like V norm, then bone transforms, but like as a mat 3 at bone transform index. We're supposed to like lerp between two things, I think. Right? So can we do like a bone? Let's just not think about normals. We'll come back for these. Normals need bone transforms. But let's just not think of that first. So the bone transform is going to be in like a global transform, right? Like we're going to have like the bone transforms are just going to be what we see for the bones, right? Like this. And so like if we are over here, like this is a bone, this bone was like vertical like this, just straight up, right? And before any animation was applied, it was just kind of like T-posing, right? And so we have to somehow get from like T-pose plus weight. It's like we want like the difference from the T-pose to where it is right now, right? That seems right, because like we're just kind of like constructing a transform based off of this object's location, translation, and shit. And like its original position was not in the center of the world, right? So maybe that is what they were talking about with this like there's like some sort of like inverse transform shit that they were talking about, right? If we look at like is this going to be like Handmade Hero 500 episodes or so because I'm into it? Unlikely. I usually can't focus on something for that long. But we will see. I won't make promises anyway, in any way. So on the skins thing, they have inverse bind matrices, which could be. It would make sense to me that this is like, give me like the root position or something. You know, you know. Yeah. Yeah. Can we look at like what we're doing to apply the animation? Animation runner. Here we're like, yo, we got some translations. And on each iteration of this thing, we're literally just like assigning the translation to this guy. And then this translation will be used to construct a transform for that bone later, which means that whoever populates translations here is like the guy, right? So in storage, we're going to be like translations append here, probably. For animation, for each channel in the animation, we like just append this translation in like world space. Or I guess kind of like local space. Yeah, this is local transformation relative to his parent. And then we are constructing a world transform out of that for ourselves later. Uh-huh. Okay, so we do need to look at whatever this inverse thing is. And Magetsub is saying inverse bind matrices kind of negate the default pose from the pose. That like makes a lot of sense to me. So let's take a little look ski at that guy. I think that makes sense. And how can we like validate what we think this like inverse bind matrix is? If we apply this to the bone transform that we're rendering here, if it is what I think it is, I think we'll just get a lot of bones that are pointing up and wiggling around. Like almost every single bone should be like at the origin, pointing towards the green axis a little bit, right? It'll kind of like rotate a little bit as it's like doing like its little animation. But I think that if that transform is what I think it is, every single bone should be pointing like relative, like they should all be rooted in at zero, kind of like going like this. Maybe like bumping up and down a little bit too or something. Maybe this way. Okay, yeah, let's look at that. So we're doing a little side quest here for inverse bind matrices. Okay. So where did this thing come from? It was in skins. Properties reference skin inverse bind matrices. The index of an axis containing floating point 4x4 inverse bind matrices. Okay, so we need to get this somehow. So when we like loading the gltf, I guess the export of this thing is going to have joints. I think. First joint and last joint. Joint IDs, maybe? We're gonna export these guys. And we are also going to export inverse bind matrices, which is going to be a bunch of transform 3Ds. Fuck it. Fix me. Maybe this should live in store, like global storage somewhere. I'm not really sure. But like we are gonna have to get this stuff out. Okay, so then when we have this like armature builder thing, he's parsing the armature, and this guy is the one who looks at each of the joints. So on append here, he's gonna have like output joints IDs as like some like array of object IDs. So like we these guys, they come in as like an index into the node array from the gltf. We're like merging a fuck ton of gltfs together, so they go into like our global storage, they get an object ID, we write that shit down. That seems straightforward enough to me. So we just say like self, joint IDs append wherever the fuck we do that lookup. Yes. Okay. Does that make sense? I think so. I think so. And then here we are getting the translation and stuff. What is this like TXR? So this is from node translation. And so here we should also probably like write down the inverse transforms. Inverse bind matrices. These are going to be like a bunch of transform 3Ds, and these are going to come from somewhere. I don't fucking know, man. Joint IDs is like a runtime bounded array of object IDs initialized with like this allocator and like 100 of them as the max. Like we might have 100 joints. We probably won't. That's too many joints. Too many joints. So this will never get hit. And this guy probably wants to be the same thing, where we have like some array of transform 3Ds here. And this thing should be kind of like snake cased. Okay, we're getting somewhere. This is starting to make sense. Okay. Nice. Okay, so now we have to make sure that like we increment these guys in lockstep, right? So we should be doing like try self inverse bind matrices append like inverse mat, right? And where does inverse mat come from? Well, it must come from like the joint sampler or something. So like what are we looking at here? We have like node ID here. So we like go for self joints. We go like for joint index here. We've got the joint index. So this is going to be like an index into array of the joints thing that points to which node in the gltf node hierarchy this is representing, right? So that means that here we have to do like something like this. This is so strange. My brain is not grokking this correctly. Can we get the node ID and the like transform here? And then this guy just is like, here's the transform. Like this. Seems kind of reasonable. Okay, which means that now here we need the transform, which we can get because we have like the... So this is like skin joints at joint index, and then we should have like some sampler here, I guess. So we should have like matrices is loader gltf accessor data at skin dot inverse bind matrices. Right. Okay, here we go. Here we go. We're getting somewhere. Okay, so skins has a field on here called inverse bind matrices, and this is a usize. This thing has to exist. He can't not exist. So this is like some set of bytes. We say, let's look at the like metadata of this guy. So accessors at this guy should have like we should be like seeing floating point 16 chunk. We should be seeing like floating point mat4s, I guess. So it's like we should be seeing floats, and the type of this thing should be like mat4. Yes. Okay. Okay, we're getting somewhere. So now we just have to like parse out the matrices. So we say like, this is the matrices buff, because he's got a lot of stuff. This is like a view of like U8s, so we need to convert this thing into matrices as a set of floats. Bytes as slice. F32, matrices buff, and then here we can construct the transform. So this, I guess, is like mat 4x4 that we were like manually constructing his internal data out of the content of matrices. So we hope that this is fucking row major. We don't know. Like, is it row major? Accessors of matrix type have stored column major. Fuck! Okay, it's fine. It's fine. Okay, so column major. This is at joint IDX times 16. Matrices end is joint IDX is the start plus 16. Okay, that's promising. We can just mem copy this shit in, I think. So like we have a mat 4x4. We're undefined, right? We're like, let's copy that shit. So mem copy from matrices at start to end. We're copying from there into the transform data. That should be fine. This thing probably has to be a slice here, and then here we can append with the transform of transform inverse or something. I'm sure that we have something along those lines. Invert. Because it's column major to row major. Okay, he's not happy. Why? What's he fucking pissed about? No field named invert. I saw it with my eyeballs. Oh, transpose. Invert's the other thing. I'm a dumbass. Transpose! Okay, so now, what? 486. This guy's like, yo, bitch. I need this fucking transform, baby. Which we don't have. Fuck my life. Because he's like walking up like the parent hierarchy and making sure that like all of the references are kind of populated there. Which means that like this has to be parsed in this guy somehow. Great. Cool. Love that. Love that. So for each of my children, I set the parent. We could just not do this or something. Yeah. So if we use like the identity matrix here, this is a mega hack. Then I think that we can just kind of unconditionally, like, we short circuit this thing if we've already injected this guy, and we just don't do that for the transform. Which doesn't work. Fuck my life. Fuck my life, fuck my life, fuck my life, fuck my life. This is too hard. Okay, so this guy needs to be able to, like, instead of just using transform here, he needs to, like, extract the transform at this point. So, wherever the fuck we were just doing all this stuff, we just kind of move all of this, like, into whatever the fuck this is. Boom. Right? And now we just have to, like, think about how this fits together. So, uh uh-huh. So this is gonna end up being somewhere else, I think. Here we're gonna have, like, on initialization, we're going to inverse bind matrices data, I guess, is gonna be some sort of, like, set of floating point data, which means that we kind of do this part where we kind of, like, pull that shit out and turn it into a slice of F32s. This happens here. Right, so this gets like a loader, which is like gltf loader. Now we get like we do this stuff here, and we probably pass in the skin as well. Maybe we actually don't do this. Maybe we just pass in this guy like raw. Inverse bind matrices data like this. That feels like it could work. Okay. So then we kind of get like inverse bind matrices data here. Sure, blaze it, I guess. Then down here, we need joint index, but now this should be like inverse bind matrices data, boom, and inverse bind matrices, we append, you know, this transform in transpose. Okay, that's a maybe. This is all fucked, but that's fine. Now there's like joint index here instead, and whoever calls this guy is now gonna be fucking pissed off. So what do we fucking pass in here? We do like this stuff. So I guess we can only handle one skin for now. Because this guy is using what? No, we can fix this. We can fix this. This guy has a field that's like set inverse matrix data. Yes. Oh yeah, we're getting somewhere. Armature builder here, he takes in this shenanigans. Oh yeah, yeah. Okay, yes. Okay, and then inverse bind matrices data is by default empty here. Oh yeah, tell me that's not cool, that's not awesome. Now here we go, we get the data, we convert it, we say armature builder set inverse bind matrices data to matrices. Boom, boom. Okay, then we pass in this and we pass in the joint index. And then this stuff gets set over there. Bing, bang, boom. All right, that was not trivial at all. Not in the slightest. Now this guy's like, yo, I'm mad. Sure, fuck you. Append. Fuck. It still doesn't work. Ah! It still doesn't work because his children are using node IDs, but we need the joint index to look up the inverse bind matrix, which means that we need to look into the joints array to figure out which fucking node ID it is. Fuck. I hate my life. Everything's so hard. Okay. Joint IDs. We just do the same thing. Oh. Bum. Okay. So we get some like joint IDs in here, and then in here we're gonna be like joint index. Like next joint index is like stud mem index of scalar in our joint IDs. But we can't fucking call it that. Raw joint IDs. I hate everything. Okay, and then we're like, yo, where is this guy? Wait, is it like that? Yes, because we need an index into the matrix. Fuck. Child node ID. Okay. Or else, unreachable, probably. We just fucking crashy. So now this can be passed to the next joint index. God damn, dude. Okay, this guy's like raw joint IDs is nothing. Then when we set this guy, we need to set with the joint IDs. Boom, bing, bang, boom. This thing's mad because we need to write review size here. Bam. Now here at the very end, we spit out the joint IDs, which is going to be like, you know, try self allocate arena dupe these like fucking object IDs from our builder. Like something like this. He's mad because like this thing's object IDs, this thing is items. Okay, fix me. This allocation is on the wrong allocator, but I don't give a fuck right now. You can't make me give a fuck right now. And then what was the other thing? It was like the fucking transforms. Inverse bind matrices. God damn, dude. So this is like we're copying some math transform 3D from like inverse bind matrices items or something. Oh my lord. Matrices. That sounds right. Inverse bind matrices. Did I spell it wrong? Inverse bind matrices like this. Okay. Okay. Oh, please, sir. Please. Please compile. I'm gonna lose my fucking mind. Okay. Now, we need to like apply these inverse bind matrices somewhere. Somewhere. Renderer. Model renderer. When we like render the bones, main render bones, show bones, we do like inverse bind here first, right? So we go model inverse bind matrices. At what? These have to be like attached to some object ID or something. Says the bone iterator is giving us bone IDs, which are object IDs. So that means that like this thing needs to have like an object ID, which means that like this should really just be like a hash map here or something. But I don't want it to be. So I guess we find in this joint IDs list the object ID. Oh! Inverse bind matrix index is like we look at the model stood mem index of object ID. We can't just do a comparison with object IDs though. So we do a for loop. 4 0 2 model joint IDs len I if I is equal model joint IDs I value is equal to whatever the fuck something bone ID. Yes. We set the transform, the like bone transform, yes, to something. It's like the model inverse bind matrices at I. Yes, which means that we have like bone transform, like inverse mat is like identity by default. Oh, thank God. Thank God. It feels like we're there. So we go inverse mat world transform then inverse mat, and this should just like fucking send it back. Please, sir. Please, God, please. Please let this be right. Okay, bones. I mean, that's not that far off from what I was saying before. It's not perfect, but this is like at the very least something. Is it the other way? There's no way it's the inverse matrix then world transform, is it? Okay, that's also something interesting. What if we just look at the inverse matrix itself for this bone? Okay. So like axes are wrong. Axes are probably incorrect. Because we have fucking. Oh, that's so painful. That's so painful because we have left-handed coordinates and they have right-handed coordinates, and so we have to like fuck up all of these matrices. We can't just read them as is. Oh God, fucking damn it. Oh fuck me, fuck my life. Uh, I don't know if you can just invert X here. We could try it. Why do I make everything so hard for myself? Why did I do this? Why, why did I do this to myself? We could have just used right-handed coordinates like everyone else in the fucking world. Could have done that, but no. No, we had to use left-handed coordinates because I can't figure out why Z goes backwards. It hurts my head too much. So we have to do it this way, and now I just fuck myself. 1, 1 here, not 0, 0. Dumbass. We don't scale to 0. Scaling 0 makes it infinitesimally small. What does this mean? Who fucking knows? Why are these over here? I feel like if we look at this model, his feet are like what is happening? You know? You know? Like these have to be his feet. And his feet are like they're like send them fucking along the x-axis? Like why? Why? Shouldn't they be coming up? Unless they're not his feet, what else would they be? What else would they be? What are these matrices? What are they? What are they? They're like, we negate the effects of the transforms, was what I thought. It's so strange. Like, these must be his arm bones right here. Why are they stacked vertically? That doesn't make any fucking sense. Oh, I guess we don't have the world. Okay, world transform. Then this shit. Let's see if that tells us anything interesting. No, this is just being like fucked again the way it was before. Hmm. This blows. Okay, we also let's just look at the inverse matrix again, kind of just as is. Let's see if we can try to infer something about these things. So we did do a transpose somewhere. What happens if we don't do that? Right, maybe. Maybe I was wrong about needing to do that. Maybe that's confusing. Bop. Nope, definitely. Okay, okay. That's some confirmation that that transpose is important. Okay, so that gives us a lot of like confidence in some ways, right? Because clearly these matrices at least are doing something that's like not fucking like absolute batshit crazy. They're like real matrices. They're the bones still look like bones. That's kind of hype. Now, okay. There's like so many options for where we went wrong here. Like so many fucking options. So let's undo. Let's like make sure that everyone's in the right coordinate system. Although that shouldn't matter here, actually, now that I think about it. Because we're not actually doing anything with that animation, so let's not do that. Okay. 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 So. It seems like maybe this is reasonable. Okay, can we not? Let's not run the animation. Okay, so if we just never start the animation, the bones should be T-posing. I think. I think. Okay, so if we do this, and then we go back into wherever the fuck we're trying to render these things, and we go like show bones, and we just show like their world transform, right? None of this inverse mat stuff. Let's just make sure that this is like a T-posing guy, right? That'd be kind of hype. If it's not, then we're confused. Okay, that's good. Mr. T-pose. Okay, so now we take Mr. T-pose and we say, then inverse mat, please. What does that do? Because maybe it was the fact that he was running is kind of like throwing us off there. Boom. Okay, pretty clearly not correct, right? So now we think about it a little bit more. We look back at the world transform here, and we try to figure out like what axis he's on and stuff like that. So let's kind of just, he is facing forwards in Z, which makes sense. So this is kind of like what the base positions of all these bones are. Let's kind of like write that down for later. Now let's look at the inverses and try to see if we can like glean any information here. Hard to glean any info. So this, I suspect that's what's happened here, is that like converting this matrix, this like arbitrary 4x4 transform from right-handed to left-handed is like not behaving the way I want. Right? Because like the fact that this guy's 2 feet are pointed like backwards on X is just strange to me. That's just weird. You know, because like everything we've seen, everything everywhere has us like pointing forwards along Z, and now he's pointing like backwards along X. So like, why? Oh, that's kind of interesting. If you right click on a window, that doesn't bring it to the foreground, unless you right click it twice. Dude. Okay, so I click on color paint. I right click on this window. No, it does not come on top. I do it again, and it does. What a what the fuck is with software? Um, yeah, that's interesting. We're definitely seeing that like all of the, yeah, they're all kind of lined up, I think correctly. Oh, you also see here that these guys are all kind of flat way, and here they were all kind of like up and down way. So that's kind of interesting. Um okay. And when we got like when we're fixing our left hand to right hand coordinate system, all that's doing is inverting x-axis. So for the most part, I think that should behave kind of. I don't think that's the bug. I don't think. Could be. We could look up like rotate, like, let's ask the idiot here. What 4x4 transform would I use to convert from left or from right to left-handed coordinates? E.g., I have some combined rotation translation, and I want to do it with the x-axis inverted. Is he just going to tell me to scale -1 up front? Yeah, he is. Which does kind of line up. Oh, yeah, he's saying do it at the end. Which does that was my first guess, right? We did do this with like an inverse mat, then scale by like -111, which is the same thing. And so like the fact that he's saying that lines up with my understanding. Now, of course, the idiot's an idiot. We have to remember that. He doesn't know what the fuck he's talking about ever, right? But the fact like if we can get some confirmation bias out of him at the very least. Okay. We could try confirming that this is actually doing something. So like let's just do like const inverse mat is equal to a block here, And here we break the block, right? And then if we make it to the end of this thing, we crash. I don't think this is happening, but I do want to confirm that it's not happening. Okay, let's just see. Yeah, okay, so that's not, we're not crashing there. So what I really don't, we maybe should look up more, we could read a little more closely what this thing is supposed to be. Inverse bind. So the index of an accessor containing the floating point 4x4 inverse bind matrices. The index of the accessor containing the blah blah blah, its accessor count, blah 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 blah. Okay, but like, what is this thing? You know? Property points of an accessor. So the order of the joints is defined by skin joints, and it must match the order of the accessor elements. So this is what we guessed, right? We're looking at like our joint index, we're tying it back, and we have one inverse bind matrix for every object ID in this thing, which seems pretty fucking reasonable. Maybe it's time to start looking at like at what these are, right? So can we find, can we color this according to its bone ID or something? Or like we look in Blender and we can like look at our bone IDs. So we know that like, okay, so like bone 2 is on his right arm, right? So let's like look at the gltf file. And we look for bone 2, right? So this is, oh god. Maybe we just kind of filter everything. Yeah, maybe it's easiest to highlight bone 2 or something, or maybe we like in the gltf parsing. We like look for the name bone 2 on the objects somewhere. So wherever like we're ripping joints, I guess, we're like, target node is skin joints at joint index. Okay. Target node ID. Target node is like from the gltf, you know, at this nodes, at target node ID, like this. Now we should be able to look at the name of this guy. So if target node name is like, if this is like bone 2, then we should be able to like glean some info. So this is supposed to be his like shoulder, his right shoulder, right here. And can we like look at the fucking thing here? Can we look at like matrices at, oh god, start is like joint index times 4, no, times 16, and is joint index start plus 16, right? And then we like print out the matrix that we get there. So 4, 0 to 4, for, this is like I, like, I don't know, row and, or column major. So I guess we want to print row major because that's how my brain works. So we go like this, and then we go like, for each line, we print a new line. Okay. Yup. Yup. And then here we're like, print the fucking thing. So print, like, I don't know, man. It's like matrices at start plus 4 times column major, so x plus y, I think. That feels kind of right. I don't fucking know, man. Let's just kind of see. We probably also, okay, so here. So on his right arm, we see like a pretty heavy rotation around something here, right? These 4 parameters here is the rotation. Then we see like this translation. Okay, so this translation is, let's ignore the rotation for now. This translation is mostly negative y, a little bit negative z. Now, does this change anything? Like, if the rotation happens, I don't know. I don't know. Okay, but the bone has like 1 root. So I think the rotation here shouldn't matter. It shouldn't matter. Okay, so what does that mean? In our world of our guy, his right arm is along the x-axis, right? That's where it should be. Should be along the x-axis. So it's weird. Oh, but it's local, his local y. Aha. Is that how this works? So if he's rotating around I need to look at the rotation matrices. Okay, so which one is bottom left corner? None of them. That's weird. None of these like axis aligned rotations are in the bottom left. That's kind of lines up with my understanding of what these things are supposed to be, right? So like we're supposed to be bottom right, corners, or top left. Bottom left is very strange as far as I'm concerned. I don't know what the fuck that rotation is. Unless like you can end up in that state by combining matrices together. That's very strange. I would never have expected to see this. But you maybe could get here by composing some other rotations. Unless I'm confused and this whole thing, if we transpose this, we get a bunch of stuff down here. That doesn't make sense. All right. Yeah, that's very strange. We could maybe punch this matrix. We could ask ChatGPT what it thinks this matrix is. That's like maybe, you know, a bit of a twist. So, what would a rotation matrix of 0, 0, 1, -1? Whoa. Yeah, sure. 0, 0, 0, -1, 0 represent. 90-degree rotation around the positive z in a right-handed coordinate system. I mean, that's reasonable. So, yeah, I mean, that's not wrong, right? 90-degree rotation around z. So why the fuck do none of our rotations look like that? Why does our rotate z look like this? Right, like shouldn't like why do I think that the -1s Let's think about this. If y is a large number, doesn't that mean it becomes a large z question mark? In which case the rotation would be happening around a different axis. Is that stupid? Is that stupid? You have a large y, it ends up at some z value, which is wrong, right? That means that would be rotating around x. You have a large x value, it ends up at some y. Also strange, right? So you're kind of going like up from x to y and also down from y to z at the same time. Where does z end up? Z ends up at positive x. So just fuck this ChatGPT guy. We can figure it out ourselves. So this is a matrix that says y, x, and they're this like this. Okay, so we end up with y, x on y. So it's like this. X on y. Y on z. It's kind of like x on negative y. Y on negative z. So it's kind of like this way. And then z on positive x. The fuck? Is that a thing that can happen? Z on positive x, y on negative x. Oh no, sorry. Z on x, x on negative y, x on negative y, y on negative x. So the new thing is y z x. Now, is this the same thing? Yes. So what is this? This is like a rotation, a 90-degree rotation on x, which would have us on like z, y, x, followed by a 180-degree or a 90-degree rotation on world, on like whatever this, like the local y-axis is. Yes. Okay. Okay. So that is like a valid rotation matrix. It's a composition of two Eulers. So it's probably like the one of them, like we don't really care about most of them in our renderer, which is kind of confusing, but probably it's like the bone is like rotating. The bone is like rotating. You could also do this as like a rotation around y first, right? So you like rotate around y to get like z pointing to the right. So it's like y, z, x, then a 90-degree rotation that way. Right. Okay. That's like, that could be right. Clockwise rotation around y, or counterclockwise rotation around y, gets him to the right arm, I think. That is like a way that you could get over here, right? Say that the bone is kind of facing like this way, so it needs to rotate a little bit to go down. Sure. Do I need to invert this matrix? Is that why I'm confused? We can't do that easily, but we shouldn't have to because it's already called inverse bind. Right? So they're saying inverse bind matrices. The axis of the index of the axis are containing in blah blah blah. Its axis count blah blah blah. How do I like use this? Inverse bind matrices data used to bring coordinates being skinned into the same space as each joint. It feels like it should be already be inverted for me. I'm just not seeing it. I'm not seeing it. I guess it's possible that we're somehow applying it to the wrong arm. And I guess it's also possible that, like, to invert the rotation, like, it does feel like we could have some sort of, like, fucked up left hand, right hand bullshit going on. It, in fact, seems very likely to me. Okay. Well, it's 4:10. Unfortunately, I don't have a ton of extra time today, so I don't think I can keep going. I think that we once again are causing problems for ourselves by working in the wrong coordinate space, but that means that we're going to have to understand the math better. So I'm going to think about this overnight. I think the rest of this should be relatively easy, right? We have managed to get, like, our weights and stuff into OpenGL land, right? We do have, like, all of this stuff, and the last step here should just be like a little, like, multiplication somewhere, right? We just have to figure out how to, like, get those inverse matrices in the right spot. So I will probably do, like, an update video when I figure it out. I don't think that this should be worth a full second stream, so I'll probably just try to, like, figure this out and then post an update when we get it. But yeah, we'll see. All right. Thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time now, so anywhere between 3.5 hours ago and now, if you're catching us live. If you want to follow up with, like, all of these projects, but you can't watch live all the time, the 2 to 4 segment gets posted on YouTube. So there should be a YouTube link in the Twitch description where you can get access to that stuff. There's kind of, like, extra 12:30 to 2 segment. We call it, like, happy hour. And that's kind of, like, stuff that I don't really just feel like titling and thumbnailing and making, like, an index for and stuff like that. So it's kind of like supplemental content. We try not to make too many, like, major feature improvements there. But you know, sometimes we do make some interesting progress. So, like, today we were working on adding our little backpack to our guy. So when our guy kills another guy, he's going to cut his head off and he's going to, you know, put him in his backpack and run around. So, like, this is what we were doing in happy hour today, this type of shit. So if you want to see that, then you can catch it live, or join on YouTube, follow on Patreon, or subscribe on Twitch for the VODs of those things. I think that's all the plugging we got to do. YouTube, peace out, and Twitch, let's find someone to raid.